All right, so here we are with cylinder head components. We're talking about the castings, valve guides, and valve seats. You see what we have here is a cutaway of a cylinder head, and it's all been painted and chromed and polished. But we have on this side of the cylinder head, the right side, and we can actually see the fuel injectors right here. So the fuel injector is going to be spraying fuel right into the intake port, and that's the best place, unless you can get into the combustion chamber, to shoot that fuel, because it won't be up in the intake manifold cooling off and raining gas. So with the injector squirting down into the port, it goes right to the valve. When the valve opens, that injector squirts, and then the air that rushes past grabs the fuel and it brings it into the cylinder. Piston goes up, compresses, then there's power stroke, and then comes back up for the exhaust valve to open, and it pushes it all out. And remember, the intake valve is larger than the exhaust valve. All right, so cylinder head castings. Cylinder heads are usually manufactured by way of casting in one of two materials, and they could be cast aluminum or cast iron. And the idea of casting, if you see in this picture here, it may not make a lot of sense, but these are molded pieces or molded sections of sand, and they are the shape of the intake and the exhaust ports. So this mold is not finished, but what this is any cavities inside a cylinder head are going to be made out of sand, and it's compressed, and it's a sand that's held together with a binding agent. And once it's all put together, they're going to pour the cast aluminum or the cast iron into the cylinder head, and once it cools enough, they'll actually break all the sand out of it. So you know, there's two ways of doing that. So what I'd like to do is, let me take a minute and go back to my arrow, and I'm going to open up this web page here. All right, so this is for a company out of Texas, and I forget who they have casting their cylinder heads, but this is the process that they go through. And here's showing in the very beginning, that right there, that's molten aluminum. Notice it's got a glow to it. When aluminum gets hot enough, it will start to glow. And that aluminum is probably, I think, 1600 degrees. Let's go ahead and flip through these real quick. So here we have the mold. This is what they're going to be packing the sand down into. And this is going to be the top side of the mold. So we're going to have, they're going to put sand inside this box, and it's a special casting sand. And we can see that there is a rail right here, and there's the edge of the cylinder head. They're actually going to be casting an LS cylinder head. And this is a permanent mold where they put the sand into to start the molding process of the sand. So this right here is a portion of the cylinder head, and I want to say this is probably the water jackets. I could read it, but you know, yeah, so it says internal cavities like the ports and water jackets and stuff like that. And this is actually sand that's molded in another mold similar to the previous one. And if you wanted to, you could take this and you could just crumple it back up into sand. It's strong enough to handle, and that's about it. All right, so here's more of the assembly. We've got a port coming through here. There's a port there, and these are the intake ports. And we have on this side the water passages inside the cylinder head. And when they're done casting this, remember, all this sand is going to come out. So here's the sand being loaded in. There's a hopper up here. The sand is already mixed with binding agent, and they pour it in there, and then somebody actually compresses it. So he excretes it off the top. There's more of the molding. These are permanent molds. There's more of the castings. It looks like it's the other side of that water jacket casting that we saw earlier. That is the intake ports. Okay. Let's see. Advertisement. There's more of the assembly there. Now notice here we have a little piece of foam right there, and if I remember right, that's actually a piece of pumice. So when they pour the aluminum in, they don't want any trash getting into the casting, so this actually acts as a filter. And then we have, looks like the top side of the cylinder head. Again, this is all sand. This is pressed together and bound with an agent. Then we have the top part of the mold is being lowered down onto the lower section. And there it is together. They have their risers and the spots where they're going to be pouring in the aluminum. So there's the aluminum. They're going to have to melt it, and these are ingots of aluminum that they get. It says it's A356, which is an alloy of aluminum that's very common for cast iron or cast aluminum cylinder heads. There's the aluminum melting away. So it says here 11 to 1200 degrees, so that's when it begins to melt, and they pour at around 1400 degrees, so it's pretty hot stuff. And here we go, two guys that are pouring. So they're pouring the aluminum into the spouts, and then the aluminum is actually going to come up through these risers. There you can see the aluminum is up in the risers. And normally they pour some sand to keep oxidation from happening, but you know, they know what they're doing. I don't know. And then here's the guy that gets to break it all apart. So after it's cooled for a number of hours, they have somebody basically go in and break all the sand out. And in doing this, they're freeing up the molding or the casting. And we see here's a casting, and notice it's got a lot of extra stuff on it, and that's all called sprue. So here's a cylinder head. We've got our fill funnel here. We've got the risers off the top. And the idea on this one is that when they're pouring in, it goes down to the bottom and actually bottom fills. So it's going to fill the mold from the bottom to the top. And the idea is that it pushes all the any impurities up to the top that have made it through the filters. Because remember, the filter was right here. The next thing that they have is where they cut off all the sprue. Now this is aluminum that was used for the risers and used for the fill passages, and they just cut it off with a bandsaw. And we can see the combustion chamber starting to take some shape here. Here we have our intake ports on this side, and I'm sure we'd have the exhaust ports on the other side. And here's what's it's an X-ray machine, so they need to make sure that these cylinder heads have no inclusions, which are cavities inside the aluminum that could cause problems. So they X-ray all of their castings, and just to see if there's any holes or cavities or what's called an inclusion. So yeah, it shoots X-rays at it. All right, so there we have some more of it. Cylinder head casting, sand. Go to the next one. Here's all, looks like rough castings that are going to get ready for machining. And then we start our machining. So this is a CNC machine where they're going to first mount the head to start the process of finishing the cylinder head. There's another CNC machine. And there we have a cylinder head which has been mounted into what's called a rotary axis. And the top of the bottom of the cylinder head has been machined, and we can see the combustion chambers again. There's the exhaust ports on this side. Go to the next one. That's just part of the CNC controls there. And then here we have a CNC machine that is, looks like it's doing more than finish work. This one is actually probably porting the ports, machining them to a more efficient, possibly larger design so that they flow more air. And this is a performance thing. And this process here is surfacing it, and we can see that we're getting down to, you know, pretty much a finished product. This machine is going to machine the valve seats, and this guy is honing the valve guides. We'll talk more about that later. And it leads us to the last one where they test what they're doing. And that's the process that cylinder head casting follows. And granted, it was a very, very fast overview, but if you want to, it's a Hot Rod article, and I'll link to it if y'all want. So cast iron cylinder heads have been used from the beginning, and they have been getting phased out in gasoline engines in the favor of aluminum, or for the favor of aluminum. Aluminum is a more expensive material, but because aluminum is less dense, and it actually is cheaper to machine because it's a softer material that is very machinable. Aluminum has become very popular with manufacturers. So a lot of cylinder heads and a lot of engine blocks are actually going to aluminum, and that'd be a cast aluminum. So cast iron is still used in diesel applications, and there are diesels with aluminum heads. But cast iron is still in diesels, and I believe it's because of the low cost of materials, because the size of the cylinder heads, it requires a lot of material, and that would be a lot of aluminum, and it may not offset the cost of manufacturing. So aluminum and cast iron are both still used, just depends on the application. So now we're into the valve guides. All right, so the two main types of valve guides are integral and insert. In the 5.3, those were aluminum cylinder heads, and they had cast iron sleeves installed in them. But if those cylinder heads were cast iron, there'd be no reason for them to just not drill holes through the head, and that cast iron would support the valve just fine, as it's reciprocating up and down. So integral guides or valve guides are only going to be present in cast iron cylinder heads, as the cast iron is strong enough, or it's a hard enough material to support a valve that's reciprocating during the engine's operation. Now, I'm not saying only aluminum heads use insert guides, but the insert guides are primarily for aluminums, or every aluminum head is going to have an insert style guide, meaning from the factory it's going to have a different material pressed into the cylinder head for the valve guide to ride up and down on. So cast iron cylinder heads can still have them, and the replacement valve guides could require the installation of an insert valve guide. So let's go ahead and take a look at our stuff over here. But what I've got are 3 valve guides, and these are they're very similar valve guides, but we have this one here, which is actually out of a diesel engine. And this is an insert valve guide, but this one right here is actually replacing an integral valve guide. So to install this one, I have to machine the valve guide, which is 8 millimeters inside diameter. I have to machine it until it's 12 millimeters out inside diameter. So if we tried to put a valve into a hole that big, we would see it'd be pretty loose. So I machine the cylinder head from 8 to 12 millimeters, and then I install one of these guides. And notice it's got this ring up at the top, and this is what's called a stopper ring that prevents the valve guide from going in too far. And that's an integral valve guide replacement. And this one is cast iron. So we come over to this one, and this is actually the LS valve guide. So this is the valve guide that's going to go into our 5.3, and it is cast iron too. It doesn't have a stopper ring or anything, but it's a cast iron guide, but it's an insert style guide. And these are both cast iron. And then we come over to our next one. This one here is what's called the material is bronze manganese, and it's an insert style guide. This is actually for an R35 GTR, and it's made out of bronze manganese, which is better for high temperature, high load, because cast iron tends to gall against steel guide or steel valve stems. But I installed these, I sized them properly. But this one is, to install it, I have to remove the original cast iron valve guide and install this one in its place. And the way that it's done is this is machined to the same outside diameter as the stock valve guide, and it's just hammer out the old one, hammer in the new one, and you're good to go. So back over to the PowerPoint, we've got just cut away the cylinder heads. So here on the left one, we have a cast iron cylinder head, and notice that it's been cut away. So somebody used a bandsaw to cut this head in half, where the valve is actually riding right on the casting, and there's no other intermediate material or sleeve. So this is our integral here. And we come over to the insert style. We have an aluminum head because notice the material is nice and shiny and bright. It's made out of aluminum. Aluminum is softer than cast iron. And pressed into the cylinder head is a guide. And this is a cast iron guide pressed into an aluminum cylinder head. And that's an insert style. All right, so valve seats. So valve seats are the sealing counterpart for the valve. When the valve is closed, the face of the valve is resting against the valve seat. There's different types of seats, just like valve guides. There are integral valve seats where the valve seat is actually made out of the original material of the casting. So if you have a cast iron head, you could have an integral valve seat. The insert style valve seats, it just depends on the application. If it's an aluminum head, it's going to have an insert valve seat. If it's a cast iron head, let's say it's a diesel engine, it's more than likely going to have an insert seat because modern diesels and older diesels have valve sealing requirements that cast iron may not be able to address. So integral and insert. So this picture here, again, another cylinder head that's been cut in half. We can see the valve. This section right here is the face. And this is the valve seat, this part of the cylinder head. When this valve closes against the head, the valve seat is what seals the combustion chamber from the port. And this one here, it's part of the casting. In this picture on the right side, we see that we have this little section here that is, it's actually pressed into the cylinder head, and it's a ring. So we're only looking at what's called a section view, and that valve seals against this ring, and that ring is pressed into the cylinder head. This is the insert style. So we have our integral and then insert. Now if we come over here to the other camera, what I've done is I've got a valve seat ring, and this is an insert style. Now this could replace an insert seat, or it actually could be a replacement for an integral seat. It's all just the dimensions. And what I've done is I've actually cut this one apart. So we're going to see some angles in a little bit, but this one's been cut apart and this one is still whole. Other components of the cylinder head. We have the valves, the springs, the spring retainers, the spring locks, and the valve stem seals. So the valves are the controlling component that's going to be pushing it's going to be reciprocating up and down. It's going to be sealing the port from the combustion chamber. The springs are what closes the valve. The spring retainers are what the springs push against, and the spring locks are what the spring retainers push against to pull the valve shut. And the valve stem seals are there to control the amount of oil that's allowed into the stem and guide area. So there's enough lubrication, but not so much that the engine burns oil. All right, so we got our valve here in the picture. We've got the tip of the valve, and that's that narrow end of it. Then we have our keeper groove, or the valve lock groove. Now this could be, a 1 groove, or it could be a 3 groove. Or if you go back old enough, they'll have 4 groove valves. The stem is the highly polished area, which is this section of the valve right here, and that's the stem. The valve face, the valve head, this is all the valve head. So everything in between this line and this line is considered the valve head. The valve face is the sealing component. So when the valve closes against the cylinder head, the valve face is what makes contact against the seat. Then we have our margin. So this right here is normally going to be about a 45 degree. So it'll be 45 degrees from horizontal. Okay, let me make that a 5. There we go, 45 degrees. And this section right here is the non-face area. It's going to be a vertical or 90 degree. And this is called the margin. The margin is a place where we would measure the life of a valve to see if it can be machined again or see if it just needs to be replaced. And then of course the combustion chamber side, which is the bottom of the valve right here. That's the combustion chamber side of the valve. And the fillet, we're not too worried about the fillet. But those are the components of the valve. Now, Gasoline engines are almost always going to be 45 degrees, but there are diesel applications that are going to run a 30-degree face, meaning this face right here won't be so steep. It'll actually be, and I'm going to exaggerate with my drawing here, it will be, if I can get that drawn back, it will be a much less steep angle, obviously by 15 degrees. So cylinder head components, again, with valve cooling. So a valve is just hanging out there in the abyss as it's opening and closing and opening and closing. And the valve, especially the exhaust valve, because it gets combustion chamber on the combustion side and it gets exhaust temperature on the port side, so an exhaust valve gets really hot. But the rule of thumb, or I wouldn't say the rule of thumb, the rule is that when that valve closes, it's going to dissipate 75% of its heat just by touching the valve seat. So if something keeps that valve from closing against the seat, whether it's a piece of carbon, a piece of trash, or something wrong with the valve train, the exhaust valve will get hot enough to melt, okay? And that is really hot. That's 2,000 degrees and up. So the valve is going to get rid of 75% of its heat through the valve seat. The remainder is going to go through the stem and then through the spring locks and the retainer and the spring and oil splash that way. But remember, the exhaust valve gets hotter, but they both, the intake and exhaust, are going to get rid of 75% of the heat in contact with the face. All right, so I'm going to take this. Let's take this guy here. So I've got a close-up shot of the valve ring. So I've taken the valve seat ring that I have cut, and I'm just going to demonstrate some of the angles on this. Let me try and hold this guy stationary. There we go. So this one here, we haven't talked about it yet, but when we get to it, we're going to be talking about a top cut, a seat cut, and a throat cut or a bottom cut. So there's three angles. So when somebody says you have a 3-angle valve job, well, that means you have 3 different angles on the seat. So before I point out the angles, let me take a valve and I'm going to close it against this seat. So here's my valve. Let me show you the valve first. Let me see if I can get that in the shot. There we go. So we've got our valve. See, here it is in the shot. Let me focus this up a little bit. And some of the points of the valve that we saw, like this section right here is the valve face. Okay, so this is upside down of what was oriented in the image on the PowerPoint. And then we have this section here, which is the fillet. Or, sorry, margin. This is the margin. And then this section right here is the fillet. And then we start down the stem right here. So what I'm going to illustrate is how this valve face seals against the valve seat. So let me reposition this valve seat again, get it in focus. There we go. Scooch it back into position. There we go. Slightly magnetic. That's not good. And then if I take this valve and I close it down against the seat, you can see that we have, so hard to do. There we go. So you can see where this 45 degree meets with the 45 degree on the valve face. So the valve seat angle and the valve face angle, they meet up and they close against each other, and you see it seals. That's a little lower than it should be. Right about there is about perfect. So this guy just opens and closes, opens and closes, opens and closes just like that. And we have our valve seat and our valve face. So real quick about the angles. Like I said, there's a top cut, a seat cut, and usually a throat or a bottom cut. So the angles that these things normally are, like I said, the valve seat is usually for a gasoline engine going to be 45 degrees. So this will be 45 degrees as measured from horizontal. Okay, so the horizontal of the screen is our 45 degrees down from it. The bottom cut, this one here, this is a unique ring because this one is custom made for this company. So we have 45 degrees, and then our throat cut is usually going to be a 65, a 60, a 65, or a 70. So this one looks like it's got two. So it's going to have, looks like a 60, and then a 70, and then this one is at a 90. So this one is just a straight down cut. The very top on the seat ring looks like it's either a 5 degree or a 0. So we have top, seat, and then throat. And this one has a secondary throat and of course the inside diameter of the seat. But this is a valve seat ring, and this has been cut on purpose just for this demonstration. Okay? Now I've got another one here. This one is of a slightly different design. Let me see if I can get that into the frame and focus. There we go. But this one has had something done to it. So we can see on this valve seat we have our top cut at the very top here, and then we have our seat, and then we have our throat cut, and then this one comes down to a radius for the inside diameter. And again, this was custom made for the manufacturer. But this one has been machined before. And the way I can tell is by looking at the top cut. So if we look at that top cut in this image, we see there's a little bit of a swoop up like that. That means somebody has machined the seat to where there's a rim, a ridge all the way around the outside of the seat. And this is improper. This shouldn't have been done that way. But again, we've got a top cut. On this one, it looks like it's a 0 degree top cut, 45 seat, and then this one's probably a 60 degree throat cut. Okay, so the next thing that I want to show you is the difference between a 30 degree valve seat and a 45 degree valve. All right, let me see if I can get them into the picture. All right, so here they are. These two valves are parallel to each other. We can see the one here on the right, the angle of the valve face is much less shallow than the one here on the left. This one is a 45, this one is a 30. And they don't interchange. And diesels are usually the ones that are going to be running a 30 degree valve face angle.